In an account of a vivid waking dream by scientific heretic Immanuel Velikovsky, he was brought a manuscript. It was a self-written manuscript on celestial mechanics by an unknown stranger. In this account, upon reviewing the work, Velikovsky almost immediately and distinctly got the impression he was dealing with a unique mathematical genius with an unparalleled grasp of the physics of motion. Despite being so awestruck, he asked the stranger why he had not alluded in any way to the work of James Clerk Maxwell. "Who is Maxwell?" replied the stranger. Slightly surprised, Velikovsky answered, "He formalized the work done by Faraday on his groundbreaking investigations into electromagnetism." The stranger didn't look any less confused, and he asked, "And what is electromagnetism?" Now this really startled Velikovsky, who immediately had to ask, "May I ask your name, sir?" "The name is Newton," he answered. "So I said Newton." Now, it was not Isaac Newton that corrupted anything in any way. Newton was undoubtedly one of the greatest, possibly the greatest scientist that ever lived. But in the 1660s, there was the lodestone. They knew about magnetism a little bit, but basically almost nothing was understood about electromagnetism as a scientific phenomenon. And the pillars of modern science were built in those days before they were understood, and the sciences involving understanding electromagnetism were kind of added as a layer on top, rather than woven into the fundamental understanding of how the universe works. And that's really where things went a bit pear-shaped. It was Einstein, or rather the followers of Einstein, and the quantum approach, the fundamentally flawed quantum electrodynamics approach that led science astray more than anything else. So this giant assumption has basically crept out there, and this assumption says that there is basically no fundamentally charged universe, that it's a fundamentally charge neutral universe, or any pockets of charge that do exist are small, and ultimately they're going to get cancelled out because the natural state of things is to be charge neutral. Talk about throwing the baby out with the bathwater, because everything in the universe that is of any interest to us, anything at all, involves the movement of charge. So the movement of charge is the opportunity for life, whether it's a proton gradient or it's the opportunity for most cosmic dynamics. Everything from a bee doing a dance on a flower is electrically charged. The bacteria in your gut are electrically charged. Your nervous system, your brain, all our technology, of course, all of it is basically electrical or has an electrical component. Then you've got to look at the sea, and you'll see that fish are very electrical in the way they navigate, sharks, most birds in the way they navigate. In fact, everywhere we look, we're just discovering new aspects of electromagnetism. the last frontier, say, where the most resistance is going to be met is with the space sciences, because for a long time it was believed that electricity doesn't move through space. Space is a vacuum and you can't have charge moving through space. But of course you've got the solar wind, which is moving charged particles. And what's the definition of electric current? It's moving charged particles. So in the field of the sun, charged particles will move. They call it the solar wind, but of course it's not a solar wind. It's not a wind at all. It's nothing mechanical. You can't leave the massive gravity of the sun as a charged particle flow away, hit the earth. Some of the particles do, creating our aurora, which is now accepted as basically the charged particles from the sun interacting with our atmosphere, going from pole to pole. And if you don't hit the magnetic field of some planet along the way, you keep accelerating. This is not how gravity works. Gravity doesn't keep accelerating. Charged particles in the sun's field do keep accelerating beyond the orbit of Pluto. And it's the same way we accelerate charged particles in particle colliders here on Earth, in a magnetic field. So there's nothing different about that. That is electric current. And of course, there are going to be all kinds of consequences, like, for example, the density of charged particles nearer the sun is, of course, going to be higher. So that must mean, it has to mean, a higher voltage. Unless you want to do away with the laws of physics, there's a higher voltage then closer to the sun. This means that any elliptically orbiting body is going to be passing through voltage zones, like, for example, a comet. And that's the only difference between a comet and an asteroid or a meteor. Instead of having a circular orbit or an orbit established around a planet, they've got a highly elliptical orbit, and when it comes in much closer to the sun, it has a massive difference in the charge density that it's facing. The voltage goes through the roof effectively, and it discharges. It's not sublimating ices and gases. It's not a dirty snowball left over from the origin of the universe. It can be anything. It can be a lump of ice, I suppose, but it can be a piece of rock smashed off a planet after an impact. It can be an errant wayward asteroid. There's no sure way of dating or figuring exactly what the origin is of these bodies. But the only difference between a comet and an asteroid is the orbit. And this is something that is totally not appreciated at all. They're seen as two completely different bodies. It continues because you've got these big hero objects, you've got filaments in space everywhere, because gravity forms, of course, it forms spheres and orbital systems. It doesn't form long filaments that glow. They have these Z-pinches that form little bodies where they touch, that are the supposed nurseries of stars, that forms the spiral arms of galaxies that get driven like Catherine wheels, that all spin the same way. This notion that gravity is the all-pervading dominant force in the universe is actually absurd. We know that the space between the stars and the Milky Way galaxy, for example, is too vast for gravity to exert its effect. The galaxy wouldn't rotate; it would go. All the stars would go flying out into the abyss. And if they did have a way of staying bound together, the rotation curve is completely wrong. So the stars at the end wouldn't rotate at the speed that they do compared to the stars in the middle. So we should know that tosses out gravity straight away, doesn't it? This seems obvious to me. It just so happens that the rotation curve of a model of something called a Birkeland current, which actually predicts the relative velocity of stars, or it has velocity of stars given any 2 out of 3 variables on 100 years worth of archived data. So that effectively eliminates the need for dark matter. And we should know this because all the space plasma out there is not gas. They keep talking about gases. It's all ionized. It's ionized. It is able to facilitate the movement of charge. Charge that can move along these plasmas also creates magnetic fields, and the magnetic fields we see everywhere, tracking the spiral arms of our galaxy. We don't include them in the Friedmann equations, or the equations that the lambda CDM uses to calculate the age of the universe, or the size of the universe. How can they be there, these magnetic fields, caused by nothing and causing nothing? Again, it violates physics. So you have a very simple, obvious, and clear answer for why we don't need dark matter. Magnetic fields explain everything. Galactic rotation is not driven by gravity. And this is obvious because the complex spiral arm system is nothing at all. There's no resemblance to an orbital system like a solar system, especially with its central jet ejecting two very long, very thin beams that we can actually produce when we do the same thing to ionized plasma in a lab. It's called a plasmoid, and that explains why the galactic jets at a critical capacitance will then discharge some matter. That matter will be highly charged because it will obviously be deficient in either electrons or in protons or neutrons, and that also affects the color shifting. That and the magnetic fields both affect the shifting of the spectrum, which then accounts for the dark energy factor, why all the quasars appear so redshifted. So we'll get more into all this, but there's a very simple explanation for all the big mysteries. All of the big mysteries will clear themselves up, and none of them are in fact mysteries, and most of them are known by thousands of scientists all around the world. They just aren't known by the public and by the research stock of scientists, who is publicly funded, of course. And this is quite a wild ride, but it's something that everyone should know.
And the muon is just a heavier cousin of the electron. It has also a magnetic moment, but there is a tiny deviation from the expected, and the expected is of course that it would confirm quantum electrodynamics, known as the most precise theory of modern physics. So what is happening here? People are already thinking about new physics, or maybe there's a fifth force, because a contradiction to quantum electrodynamics is something serious. It has got a Nobel Prize and is said to be tested to an incredible 12th decimal place. But maybe you're curious, what exactly is this test? And I would like to invite you to dig a little bit into history, because I think it is imperative for understanding what is going on here. And I will assure you, you will learn some stunning new facts. I learned these facts from a Spanish scholar I will name later. And, well, by the way, these facts are undisputed. You can check every single argument in the links below here. The birth of quantum electrodynamics, so to speak, had matched so miraculously, the prediction turned out to be wrong. This error was revealed 7 years later in another paper by Peterman and Sommerfeld. And look at this. I mean, every single value is different here. And of course, again, Peterman and Sommerfeld were convinced that their result was correct, and maybe it helped a little bit that the experimental value of the time published coincidence 1 year earlier was in agreement with the result. Well, let's pause here for a moment and keep track. Until then, no theoretical result has withstood latest scrutiny. How could such negligence occur? The calculations, after all, had been reviewed and published, right? Well, not even published. A major ingredient of what is called the most precise theory of modern physics, the Feynman graph 2C, remains somewhere in the notes of people who died 10 years ago. Can you believe that? Well, if not, just check this excellent work by Oliver Conza, a scholar from Barcelona, and I can only recommend to read his 2 papers. It's incredible stuff. Conza also showed that Corpus and Kroll deliberately lied about how the calculation in 1995 and 2006 contradicted each other, and that nobody had detected the error for 12 years. But I admit that earlier I also had participated in that choir parroting that QED was a precisely tested theory. And keep in mind that practically nobody can check the correctness of such papers based on highly complicated and unpublished computer code. There were other scandals that followed, as Conza points out, and sadly not only theoreticians tinkered with their calculations, also experimentalists seem to have fudged their data, because how else to explain that in 1961 they again measured a value that precisely matched the theoretical predictions that turned out wrong afterwards. Although this could be a deliberate fraud, I don't think it necessarily is. Because if you are a researcher rooted in your community, it is very hard to disagree with hundreds of your skilled and respected colleagues. People judge against their direct perception, as the psychologist Solomon Asch demonstrated in 1953 in his famous experiment, and the social pressure is much worse here. And to remind a quote from Albert Einstein, few are able to calmly pronounce opinions that dissent from the prejudices of their environment. Most are even incapable ever to reach such opinions. And there is another confession I'd like to make. I always liked a lot Richard Feynman. His writings, his frankness, his openness, his mockery of string theory. I just couldn't imagine that his theory, his Nobel, was just a bunch of nonsense. But he even knew it, he admitted it. Aware of Dyson's destruction, he said, "The shell game that we play is technically called renormalization. Having to resort to such hocus pocus has prevented us from proving that the theory of quantum electrodynamics is mathematically self-consistent. I suspect that the renormalization is not mathematically legitimate." Yet Feynman was too superficial in his reasoning, and his biggest blunder was to be dismissive about history, because they knew it. Dirac knew it wouldn't work. Pauli said it in his Nobel lecture that you could not use renormalization. About the unsolved problem of the electron's self-energy, he said, "We will be considered the generation of physicists that left those fundamental problems unsolved." And Bohr and Schrödinger and Einstein, probably they did not comment about the idea of renormalization because they considered it an approach too dumb to mention. Indeed, it is as simple as this.